Right, started. Okay, this is a component we lost on price. We're going to try putting it on a new brother machine, which we've just set it up on. And this component was 20 minutes on a house. That's right, isn't it? So, hit the start button, go. And you notice the first thing straight away is it's pretty much machining instantly. There's no delay, it's straight into it. What's that running at? 16,000?
I'm only running the spindle at 12, but I'm actually running around 6 metres on the outside.
6 metres a minute. That's just roughing, is it, at the minute?
Yeah, that's just roughing.
So that's where you're winning. The tool change there was about a second, whereas what house is about 7 or 8 seconds.
Oh, easy. Yeah.
So I guess that's where one of the areas where this machine wins so much over a house. Not just the spindle speed and the movement; it's the actual idle time. There's no idle time, very little idle time. It's virtually cutting all the time, isn't it? That's the thing. And not only that, when it is cutting, it's cutting faster because of the extra speed of the tool. How many tools is this job, do you know?
Nine.
Is that all it is?
It's got all different size holders.
Does it come back in with the same tool twice though?
Yeah, definitely.
So how many tool changes? So it could be like 15 tool changes.
But you're looking at about 15,
15, 16
16.
tool changes. So you're saving sort of 7 or 8 seconds on each of them. That's a couple of minutes. Well, that's a couple of minutes just on that. So just on tool change, this is 2 minutes faster.
I will give you a definite answer when I can look at the program. Just top of my head, it's something like that anyway.
And I guess we could get it even faster if we set the other side of this plate up and did 4 at a time.
Yeah.
Well, it wouldn't necessarily be any faster, but you would get more off.
Yeah.
Per set. So you'd get less time in between changing, so which would be more efficient essentially.
Yeah.
So it's 3 minutes according to this so far. 3 minutes.
You've got that on before the clamp change. You have
right.
Nearly 2 minutes.
So there was a one up before this. There was 1 minute.
Just under 2.
Just under 2.
Yeah.
So we're actually at 5 minutes in the cycle time.
Yeah. So it's gonna finish in less than 2 minutes now.
So it's almost finished.
Yeah.
So we've gone from 20 minutes down to
6 minutes 58 seconds.
6 minutes 58 seconds. So we're 3 times faster from a machining perspective. The loading time is going to be the same, which is about 3-4 minutes, we think.
Yeah, I think roughly, because you've got to clean things down as well, you know. But to be fair, yeah, I bet looking at about 5 minutes.
5 minutes, so 12 minutes in total. That's a heck of a lot better than it would have been 25 minutes for one.
Yeah.
So we've gone from making 2 and a little bit to 5. We've basically doubled. This machine doubles the output. Yeah. Essentially, it goes from 2.5 an hour to 5 an hour. That's basically the gain this is.
You see, before I think Rob did them and he did them in the vice, so there's a lot less kind of loading time because the vice handle. So if we could think of a more efficient way of clamping, then you've got the speed of the brother, and you know whether there's some clamping system out there that you could look at.
Well, there probably is if you got to mass volume. This is only a batch of 100. You know, there's not really. It's not worth looking much beyond where we're at the minute.
No.
I don't know what the actual volume is of this component.
That's it. Complete.
And that's it. That's it. All done. Just give it a blow. So look that. 6 minutes 58.
Yeah.
All done.
Channels for that.
I don't know whether it's going to focus that. It won't. It doesn't like focusing on that for some reason. 6 minutes 58 anyway. And that's that.
Could take a bit more time off it more, but I don't know how much quality you're going to lose.
Well, that's fine. You don't want to. No, you want to keep the finishes. That'll do. Thanks a lot.
Okay, mate.